Today we're going to create some very simple game experiences. This video very much builds upon previous videos, so if you haven't watched them already, I urge you to watch the previous videos first. So, just as in previous videos, we start by importing Turtle and creating a screen. So, how are we going to make it interactive? Well, interaction generally requires two things. The ability to respond to what the user wants, and for most but not all games, the ability for something to happen in the background even if the user doesn't do anything. So if you've got a game like Sudoku or Crossword, then nothing happens until the user, touches a key or presses a button. But if you've got a game like a combat game or a time-based competition, then if you don't touch the controls, things happen on the screen and in the game environment. So, how are we going to make things happen? The first thing is we've got to use special command. We've got to use our own defined commands. Now, the way you define a command in Python, a new command in Python, is using the def command. So if you do print some stuff as a command, with a colon on the end, and then you can say print hello. And if you execute your new command, it'll actually execute all of these commands here. So this is how you can sort of, instead of having to retype absolutely everything every time, use these definition of new commands to sort of create shortcuts. So that's all the command is. This print some stuff is a shortcut for all the other commands you've just put in here. So we need a new command here, which is left. We need to turn the arrow, and that's going to be our form of interaction. So we do def turn left, '90, and that's it. So if we do turn left, you notice there that the arrow turns left 90 degrees. And if you do it again, it'll turn back. So 4 turn lefts and you're back the direction you came. So having the arrow rotate is all fun and everything, but I did promise a bit more interaction than that. So how do we make it so that the user can drive the turning of left from the keyboard? The way we do that is we tie it to an on-key press command. Turn left if the spacebar is pressed. So I'll make spacebar our control. So what's happening now? Nothing. The reason why is because we've also got to tell Turtle to listen. And now if we say turn left, press the spacebar, every time I press the spacebar, the arrow turns left. Okay, we've got an arrow that rotates. What else can we do? Well, it'd be really cool if the arrow actually moved forward at the same time as it was turning left. The way we do that is we use a timer. So a timer is a little bit different to the way that we've done motion in previous videos. We need to create a new thing to tell Turtle what we want the timer to do. Only needs to move forward a little bit. And we also need to put the timer command inside move forward, because the timer command's only fired once, so it has to be repeatedly set up. On timer, move forward, comma, 100 milliseconds. So we want timer to move forward every 100 milliseconds. Now, when we actually execute move forward, see there the arrow starting to move forward. That 100 milliseconds is 1/10 of a second. Oh no, we're about to go off the screen. How about if I press the space bar? And by hitting the space bar, I'm executing the turn left. I think this would be more interesting if we actually printed out what it's doing. So let's change the definition of turn left. And as well as doing that, we'll make it print so you can see what's happening. Now when I press the space bar over here, need to redefine this. I turned left. See, it's printing out every time I hit the space bar. How about if we move forward a little bit more interesting? Okay. Now note that the spacebar only executes that on key press if you actually click the graphic window. You can still press spacebar over here and nothing will happen. So the on key press is very much tied to the graphic window. So how can we make this more interesting? Well, we could make it draw a square. So def move forward. Okay. Black outline, green middle. Begin fill, just like in previous videos. Okay, and we're going to put screen.end fill and then screen.update. Now we're going to put an update in there for reasons I'll explain in a minute. So let's not do that for the moment. Oh, almost forgot. We need to put the timer in there. Okay. Let's come back to home again. So let's put home now. We need to move forward. What did I do wrong? Ah! I did right 50 instead of right 90. Programming is fun. Some interesting shapes being drawn there. Okay. Pushing the up arrow just to get back to this. Okay, let's get back home. Oops. So now it's executing just one square there. You know what we forgot? We forgot to add the move forward. So it's not moving forward anymore. So we're going to quieten this down a bit by saying tracer off. Tracer false, sorry. So now it's not actually updating anything. And now if we want to see anything, we have to put an update in there. Just as we did with the previous videos. Because tracer's off. Okay, and I still forgot to move forward. So it's drawing the screen again and again, but it's not actually moving. And screen.clear. And you can see now the square's moving with the arrow. Now if I press the space bar, I forgot I've got to do the on key press again. Oops, what did I do wrong? Oh, it's unexpected indent. You've got to make sure there's no spaces and stuff. Now if I do left, and it's not working. Tell it to listen. Oops. Ah, it's coming back again. So whenever I press, so a lot of the time when you do clear or updates, you've got to re-enter the on key press and listen commands. So instead of drawing a line, it's now moving a square, and whenever I hit the space bar, it changes the direction of that square. Okay, well that's fun. Well, let's turn it into a slightly more advanced game. So, to do that, we need to... So never mind about that at the moment. So we're going to define a do nothing. Actually, we're just going to tell it to stop calling timer for a minute. So that freezes the screen because even though it's continuously redrawing the square, it's not moving anymore. Gives us a little bit of time to think about what we want to do next. So how about if we turn the arrow right 90, so it's now pointing upward. So let's do screen.home, sorry. Screen.clear, so it's now not doing anything. So, left, I want the arrow pointing upwards for a specific reason. And that is I'm going to now recreate the old Lunar Lander game, or at least part of it. So I don't know if you're old enough, you might remember there used to be a game called Lunar Lander, where you had to press the space bar to control the thrust of a spaceship, and the idea was the spaceship couldn't move too quickly when it came in for a landing. So to make this work, just like our bouncing ball, we need to draw a square and it needs to accelerate downwards. So if we do velocity, equals 0 to start. Now with a spaceship, there's two forces acting on it. There's the thrust of the ship, which is trying to push it upwards, and there's gravity, which is trying to drag it downwards. So when we're going to make it so that when you press the space bar, you turn the thruster on and the ship tries to move upwards. But if you don't do anything, the ship will move downwards, and you know, in a real game it would eventually crash. So how do we do that? So we need to change the definition of move forward to it's now move down. And it'll move down by velocity. So the first thing we need to do is say minus 0.1. Minus direction is downwards, plus direction is upwards. Still need to do this, we need to do pen up. Now you can see here, the higher or the lower the velocity number comes, a negative numbers actually move backwards. So even though I said forward, it's actually going to move backwards and fall to the bottom of the screen. Now we need to draw the square. screen.clear. Obviously a square isn't a very realistic spaceship, but you can have a bit of fun with that. Okay, making it go 90 and forward. 1, 2, 3, 4, 4 sides to a square, that looks right. Update. Okay. And now we're going to make the timer point to move down. Oh, I've almost forgot we need to put the timer on the end. Move down rather than move forward. Okay, now when I hit call move down, oops. What did I do wrong? I did do velocity. Need to do one more thing here. Just to tell it that we want it to access the outer variable. You can see here that the square's moving down quite rapidly. In fact, that's probably a bit too rapid. So let's reduce that a little bit. Okay. We'll hit return there. Just to bring everything back again. Oh, didn't work out. And velocity equals 0. And, sorry. Let's just move it up a bit. Give us a bit of time. See, it's somewhere up the top of the screen now. Ah, it's getting faster and faster because the velocity keeps increasing. Oops. Now you can see here if we velocity equals 5, then it starts shooting upwards. But eventually the gravity pulls it down again. Okay, eventually, so when it gets somewhere above the screen, and it'll start falling again. So let's just do screen.home so we can see it. Oops. So let's see what velocity is. Oh, it's still a bit high. You see it's gradually reducing though, because every time it draws the square, it reduces it by 0.1, and eventually it'll start falling again. So instead of having to sort of like just adjust velocity manually by saying, so oops, sorry. Okay, instead of having to adjust it manually by saying, oh no, velocity 1, oops, plus 1, sorry. So it can go up a little bit and then slowly get diminished. How can we work this into the game? The way we do that is we do it with our friend keypress. So we do every time we do a key press, we want it to sort of like change the velocity a bit, or add a number to the velocity. So we can do this by saying def handle spacebar press global velocity let's make it 0.2 and then oops, come back, alright. Okay, starting to increase the speed. Then we do on key press. Okay, let's see what happens there. Nothing, because we... Oh, there it is. See, it's starting to go up. Giving it quite a lot of... So I was pressing the key, the space bar there. Let's just change the space bar thing a bit. In fact, I gave it too much. It's going off the screen now. Okay, we'll do the print again so we can see what's happening. Okay, let's just do that. I have to redo it because it's redefined. Oh no, our game things come back. There we go, it's starting to fall down now. But if we press the space bar, oops, with this thing here, see, every time I press the space bar, it starts moving upwards. And that's the essence of our lunar lander game. So obviously to do is we can add, detection for when it's gone too far down, get the position and find out if it's crashed. Oh, lots of spacebar, plenty of thrust there. And it's obviously not super interesting without like a rocket exhaust coming out the back, or a realistic rocket for that matter. But we've got the beginnings of a real game here, where if you press the space bar, you interact with what's happening on the screen. So the square rocket falls if nothing's pressed. So it just because of the because of the move down command and the slow increase in velocity, or rather the slow decrease down to minus numbers, the velocity, in fact actually let's just help with that. So we'll change this command so it tells us what the velocity is each time. Come on, that's the one. Okay, now we'll see what the velocity is each time. My goodness, that's moving fast. Let's bring the velocity up a bit. Oh, a bit too fast. It's going to shoot off into forever. Okay, it's slowly coming down, and now it's printing way too much for me to actually do anything. But you get the idea. You can see here how the velocity changes every time the square's printed, wherever it's gone. And it'll eventually start falling again. But if you press spacebar, the velocity increases. And that's the essence of a simple game. There's obviously more work to do. So, for example, in a real lunar lander game, you'd want to, detect when it hits the surface and work out how fast it's going to see whether the spaceship crashed or landed successfully. But yeah, I think that's enough fun for this video, and look forward to seeing you guys in the next video. Thank you for your time.